In this video, we are going to learn about the electrical capacitance. Okay? So this is your question number 5 of the EOT and the last question. So after that, guys, you can relax and you can just have a practice and then you are ready for the exam. So what exactly we are going to learn? We are going to learn about the capacitance of a conductor. So what he's talking about, capacitance of the conductor as the quotient of division of the charge, okay, division of the charge on the conductor by the electric potential. So what exactly he's talking about, C is equals to Q divided by V, charge divided by electric potential. Okay, now we need to understand, the first thing we need to understand the definition. Okay, guys, what we have, the definition of the capacitance, this is very easy. The capacitance of a capacitor is defined as ratio. Ratio means division. Division of whom? Magnitude of the charge divided by potential difference. Okay, this is easy to understand. Potential difference. So we have this formula, C is equals to Q by delta V. Fine. Okay, second thing, the SI unit. The SI unit. What is the SI unit of the capacitance? That is the farad. That is the farad. But guys, which unit we are going to use in the exam? They will give you like this, microfarad. So 1 microfarad. So what does it mean? Or they will give you 5 microfarad. So what does it mean? 1 multiply 10 raised to power negative 6 farad. Clear? Similarly, they can give you in terms of picofarad. And you need to use this formula. And you can remember this formula or equation with the help of the triangle also. So just you can place the value Q, C, delta V. And you can solve anything. If they are asking for the charge, if they are asking for the capacitance or the potential difference. So I already told you there are the 3 factors. First is the C, that is the capacitance, and the unit is farad. Second is the Q. Q is the charge and the capacitance, the unit is the coulomb. Third is the V, voltage, and the unit is volt, or you can say the potential difference. Now guys, what exactly we need to understand? We need to understand by the parallel plate capacitor and the factors affecting the parallel plate capacitor. So you can see in the diagram, this is the parallel plate capacitor. The first plate is the positive charge, second plate is the negative charge. And just remember, the positive and the negative. And this thing I already explained in a number of videos, that the electric line of force always move from positive to negative. Positive to negative. Here is your electric field. And this is the first point. Second point, what is the value of electric field inside the or in between the 2 parallel plate capacitor, which is equals to sigma by epsilon naught. Sigma by epsilon naught. Here you can say here is your electric field, and what is the value? Sigma by epsilon naught. What is the value here? E is equals to 0. Here E is equals to 0. Clear, guys? Okay. Now what is the capacitance here? What is the value of capacitance? So there are the 3 factors on which you need to focus. There are 3 factors. The first factor, which medium is here? Which medium? Okay. Second thing, what is the area of the plate? Area of the plate. Clear? And third factor is the distance between the plate. Distance between 2 plates. These are the 3 factors. So you can write medium as an epsilon and epsilon naught, area as A, and the distance as D. So if we combine all these 3 factors, then C is equals to K times of epsilon naught A divided by D. What is the K here? Dielectric constant. K equals to your dielectric constant. Okay, I will tell you how we can use all these things. Let's say in these case 1, so that you can understand. Case 1, let's say we have the 2 parallel plate capacitor. Okay, this is positive, this is negative, and you have air inside that. So what is the value of K for air? K is equals to 1 in case of air. or vacuum. In both the cases, K remains the 1. So your formula or your equation C is equals to K times of epsilon naught A by D becomes, you can put the value K is equals to 1 times epsilon naught A divided by D. And in your book also you find this formula, epsilon naught A divided by D. It means that time they are focusing air within the plates. If case 2, if they change the medium, let's say there is a conductor in between, or you can say there is a metal in between the plates. Okay, these are the plates and I place a conductor here or a metal plate here whose dielectric value is 12. Okay, then what will happen? C is equals to K times of epsilon naught A divided by D. So if I place the value 12 epsilon naught A divided by D, so can I say C new value, so which is equals to C new value is equals to 12 times of C naught, because we know na when there is an air K is equals to 1, so the value of C naught is equals to epsilon naught A divided by D. Clear? So we can place this value here. This value is here. Clear, guys? So I can simply say is the new capacitance will become 12 times of the normal capacitance if we introduce a new medium. Okay. Now there is a question. Generally they will ask you question, and from my side they can definitely ask you this type of question: on which factors capacitance depends? We have two formulas, okay, but there is a problem in one and you need to understand that part. You know, you learn about C is equals to Q divided by V, and C is equals to epsilon naught A divided by D, K times. Okay, so here what you need to understand, sometimes students say if we increase the charge or if we increase the potential difference. So remember, C does not depends upon Q and V. Okay, there is a question why. I will explain that. Because whenever you draw the diagram or whenever you plot a graph between Q and V, let's say this is your Q and this is your V, and this gives you a slope here. This is your slope, which is equals to C. So always, every time you will get a same ratio. Let's say this point you have a same ratio, this point you have a same ratio, this point you have a same ratio. It means if one value, let's say charge is increasing, in the same proportion you can say the V is also increasing. If charge is reducing, then V is also reducing. In that case, the capacitance C remains the same. So there is no impact. There is no impact on the value of C because of Q, charge, and the potential difference. This is very, very important. So guys, you need to listen this 2 to 3 times so that you can answer this question. There is no change in the value of capacitance when the value of charge or potential difference increase or decrease, because the ratio means the division of charge and the potential always remains the same. Second case, we have C is equals to K times epsilon naught A divided by D. So C is directly proportional to medium. If medium increase, capacitance increase. If medium decrease, capacitance decrease. Clear? Second, C proportional to area. If area of the plate increase, capacitance increase. If the area reduce, then the capacitance reduce. Third is the distance. C proportional to 1 over D. So if distance reduce, then capacitance increase. And if your distance C proportional to 1 over D, and if the D increase, capacitance decrease. These are the factors. Clear, guys? So this is how you need to solve the questions. Okay, now one more part, just last part. How to solve the graphs on the basis of capacitors. So all the graphs gives you two things, one gives you slope and one gives you area. What does it mean? Slope means y-axis divided by x-axis, okay, and the area means y-axis multiply x-axis. So just see the graph and try to understand what we are getting here. So let's say this is a graph we have, okay, between the, this is your Q charge and this is your potential difference. So what we get here, this is the line, okay. So this line, if you divide, just try to understand slope. If you divide y-axis divide by x-axis, so what are the values you are getting? Q divided by V. So can I say C, Q divided by V? So can we say slope of QV graph equals capacitor or capacitance? Yes or no? Okay. And the second thing, now if we multiply, just find the area, so area is y-axis multiply x-axis. So can I say Q multiply V? Q multiply V. But if you are making an area, let's say I'll draw something here. So it behaves like a triangle. So can I say what should be the area? Half times Q times V. So which is equals to your energy. Remember this thing. This is something which you need to focus, that if you are trying to find the area, if you are trying to find the area between the QV graph, you will get the energy of the capacitor. Okay, guys. So now, guys, all the questions are finished and I hope you understand each and everything. So now I'm going to finish this video by the only these words: all the very, very, very best for your exam. Do good. And guys, remember, you are a unique creation of the God. So believe on yourself, put your efforts, put your 100%, and definitely you will get very, very good marks. So guys, all the best. Take care.